Hello, so I am filming this video for explanation of task 7.1. First, we'll have task 1 for insertion, and start will have 17, and because 13 is smaller, so it's on the left side here, and 1 is smaller than both of them, so that'll be here, and obviously here will be unbalanced because that'll be 2, 1, and 0. So we do a right rotation. And 13 will be here, and there'll be 1 and 17. And now that's perfectly balanced. If we move on forward, we'll have 8. Smaller than 13, bigger than 1, so that will be down here. And then we'll have 5. That is also smaller than 13, bigger than 1. However, smaller than 8, so that will be put on the right side of 8, which will be here. Obviously, this is unbalanced, so if we just take on this part and move it here, we'll make a right-left rotation. So first we'll have the 8 down here. So we'll have 8 down here and move up 5. And then we'll move up the 5 and move the 1 down to the left. So finally it will look like 1, and that will be the 5, and that will be the 8. And then we put that all back together, that will be the 13, and that will be the 17. So now the tree is relatively balanced. I won't go through the whole list because of time limit for YouTube uploading restrictions. And now I'll have pre-made graph for question 2. Here, if you want to remove 16, for example, in this case, we'll just take this part, and that'll be 16, 15, 24. To remove 16, then we'll just bring up 15 and leave 24 there. And if we bring that back into the whole graph, that is still relatively balanced. So we don't adjust anything else. However, if we want to remove 11, for example, we'll have here 8, 5, 11, 1, and 6. So if we remove 11, obviously it's unbalanced. So we make a right rotation first, and that will be 8 will be down here, and 5 will be up. And in this situation, obviously we'll want to move 1, because if we move 6, that will not make any sense, right? Because 6 is bigger than 5, and that can't be on the left hand side. So we'll have 1 and then 6 remaining here, and then we can just bring that back into the graph in the original spot. Also, we'll have question 3. Question 3 talks about how do an insertion order so that we doesn't have to do any rotations on the graph, and that's the graph of the list. So obviously, if we want to put in that without making any rotations, it'll just be 4. So we remove 4 first, and then bring up the 2, and it will still balance on the left and right relatively. And then obviously we want to put in the 2, and that will cause the right hand side heavy, and therefore on the next one we need to put in 6. And at this stage, because they're all the same layers, after we put on 1, the order of 3, 5, 7 that goes in after 1 doesn't really affect that much, because it still is just a 1 layer difference, and that will be still considered as a AVL tree. So therefore the order will just be 4, 2, 6, 1, and 5, 3, 7 doesn't in fact matters that much. And I remember you asked me about the running complexity of insertion and deletion, I believe, and the running complexity of both algorithms should be just big O to log n in our worst case scenario.